Boys, in this video we're looking at what is a fraction and the different types of fractions. During this time of distance learning, I've had the opportunity to do a fair amount of cooking at home, and when I'm cooking, often the ingredients in the recipes that I make involve fractions. You might be asked to add a half a cup of flour, or half a cup or a third of a cup of sugar. You see these fractions popping up in the different recipes. We notice fractions in all sorts of different places in everyday life. And today we're going to look at, well, what are these fractions and the different types or different ways that fractions can be represented in the way we write them. So what is a fraction? A fraction represents part of a whole. It is a comparison of part of a quantity compared to the whole quantity. So part out of a whole. Fractional parts must be equal in order to make this comparison. So, if I said I had eaten half of the pizza, but actually what I'd done is I'd just chopped off a tiny edge and ate all of this, then that wouldn't be eating half of it. Although there's two parts, that's one part, this is the other part, that's not, they're not equal. And so it would be unfair to say that I ate half the pizza. So when we're writing fractions, how do we represent them, I guess, in mathematical language? We write them with a numerator over a denominator. So I was just talking about the fraction of a half. And so we have the part of the quantity on the top called the numerator, and the whole quantity on the denominator, so 1 out of 2. Let's look at a couple of diagrams at the bottom here to just have a look at how fractions can be represented visually. And so here's a circle, and it's been broken into 4 equal parts. 3 of those parts, 1, 2, 3, are shaded. And so the fraction out of the whole that is shaded is 3 out of 4, 3/4. To the right, we've got a rectangle that has been split into 12 equal parts. 1, 2, 3, 4, 5, 6, 7 of those are shaded. And so the fraction of the whole that is shaded is 7 out of 12. We're now going to shade in some of the fractions that are shown here. So if 2/5 of this whole has been shaded, then we've got 5 equal parts. If we just shade 2 of them in, then that would represent 2/5. This time we've got, asked to shade 2/5 of this, we've got 10 equal parts altogether. And so we would need to colour in 4 of those. It's the same amount. If you look at these two diagrams visually, it's the same sort of value. It's just been split an extra couple of ways. Okay, C, shading 2/5 of this diagram. Well, it's been broken into 5 and they look equal to me, 1, 2, 3, 4, 5. And if we shade 2 of them in, then that would be 2/5. Looking at D, 5/6 of this one. We've been split this one into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. So 5 out of 6 are being shaded. Then 1, 2, 3, 4, 5. If I just look at this half, if I do 5 out of 6 on that side, and 5 out of 6 on this side, then that would be what I would need, 5/6 of the whole, which is actually the same thing as 10 out of 12 of those parts being split up. Okay, so let's split this next one 2/3 into 3 equal parts. Well, if I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, if I split that into 3, that's going to be blocks of 4, isn't it? Okay, so we've got 1 block, 2 blocks, and 3 blocks of 4 now, and 2 out of those 3 equal parts are shaded. So I'd need to shade this one and that one. Okay, so F5/12, if I want to color in 5/12 of this, notice that being split into 6. So it's not going to be possible to do this at the moment unless I make some other splits like this. And now there's 12 parts. I can now do 5 of those. If I just shade all those 5, that will do the trick. Please complete the remaining questions on this page. Let's look at types of fractions now. The most common fractions we see are what's called proper fractions, and that is where the numerator is smaller than the denominator. For example, one we've seen already is 1/2. Another could be 3/4. Anything where the numerator is smaller than the denominator. Improper fractions, however, are fractions where the numerator is larger than the denominator. So 3/2, 5/3, 23/7. Anything where the numerator is larger than the denominator. Of course, if we wanted to flip something like 1/2, that would be the same thing as writing 2/1, which, because 1 fits into 2 equally, we could just write that as 2 wholes. Now, mixed numerals, they contain a whole number part and also a proper fraction part. So a mixed numeral, for example, would be 1/2. So you've got your whole number part at the start, followed by your fraction part. And notice it's a proper fraction, so the numerator is going to be smaller than the denominator. So 3 2/5, 10 1/3. All right, let's look at some examples now. Write each improper fraction as a mixed or whole number. So 8/5, how do we turn that into a mixed or whole number? So if it's got 8/5, then we've got more than 5/5. So there's one whole would be 5/5. We've got 8/5 parts, so we've got another 3 left. So that would be 1 whole and 3/5. 13/3. Let's look at that. So how many times does 3 go into 13? Well, it goes in 4 and a bit times. So this is worth 4 wholes, because if a whole is worth 3, or if it's split into 3 parts, then and we've got 13 of them, and there's going to be 4 of them, plus another remaining third. You might be thinking, how did I get the third? Well, if I do 3 times 4, I get 12, and I had 13 on the numerator, And so I've got those 12 all fit into the 4, and then I've got 1 left to get me up to 13, so 4 1/3. Question 2. I'll leave these ones for you to fill out. Question 2. We've now got to write these as improper fractions, so we're going in the reverse direction. So if I've got 3 1/2, that means I've got 3 wholes and a half. So my 3 wholes, if there's 2 parts in each, then that would give me 6 parts altogether for 3 wholes, and then the extra 1 will give me 7 out of 2. Now, sort of a little mathematical algorithm way to get there is to find what this value on the numerator here is. All you do is you multiply these two numbers and then add that one on at the end. So to get that numerator of 7, what I actually did was go 2 times 3 plus 1, and that gives me a grand total of 7. So if I apply that idea to part B, to get the numerator, I would do 5 times 8 plus 7, and that would give me 5 8s are 40, 47, so it'll be 47 over 8. Okay, going down to question 3. What fraction is shaded? Leave your answer as an improper fraction and a mixed number. So if 1 heart represents a whole, we've got 1, 2, 3, 4, 5, 6 wholes and a half. 6 wholes plus a half here.